A2 Maths, Rational Expressions. Right, what I'd like you to do is I'd like you just to have a go at simplifying those four expressions there. If you want a hint, then you can just carry on listening. If you don't, pause there, have a go. Okay, so my hint would be factorise. Okay, so have a go at those four. See how you get on. Okay, so hopefully, if you factorised each of these expressions, what you'll notice is that if you factorise that cubic function there and that quadratic function there, you end up with those. And from there, what you can do is you can actually cancel some of these common factors out. So the x plus 3 can cancel with that x plus 3, the x plus 1 can cancel with that x plus 1, and that leaves you just the factor x plus 4. Okay, so all four of these are very similar to that. So there we go. This one goes to x minus 4, which you can use the factor theorem and your factorising skills to work out. The x plus 5 and the x plus 5 can cancel out, leaving you just the x minus 2. How about this one? So you factorise the cubic equation on the top, and you've got that. You end up with a quadratic part there and the linear function there. The linear functions can cancel out, leaving you just a quadratic equation. Then finally, this cubic here divided by this linear function here, you can factorise it, you can cancel out your x minus 4s, and that leaves you that quadratic equation there. Now what's important to notice with this short exercise is that when you divide a cubic function, like that one there, divided by a quadratic function, like that one there, you end up with a linear function. So a cubic divided by a quadratic ended up with a linear function. Now later on, you had a situation where you had a cubic function there divided by a linear function, and what happened in that case, well, because you had an order 3 divided by an order 1, you end up with an order 2, a quadratic equation at the end. So it's important to notice which sort of functions you're dividing and having an idea of what answer you're going to get out at the end. Okay, so what I'd like you to do is, like I said, use the factor theorem and see if you can work out which of those four factors are factors of those four equations there. Okay, so again, pause, do a bit of calculation or do a bit of logical thinking, see if you can work out which one goes with which. Okay, so the bit of logical thinking I was hinting at is just knowing that because these are factors and they definitely go with one of these four, is really just matching up which parts would make sense. So for example, on this very first one, because you've got a 2 at the end, the number 2, it can only go in one of these n numbers. And there's no way you can have 2 times some other number, some other whole number to get 5. You can't do 2 times some other whole number to get 25. Same with 15, but you can get 2 going with 10. So that one there would definitely pair up with this one because there's no other numbers it could go with. Same with this. 5x at the front. That's the only thing that's going to make the x cubes. 5x times something. It can't be that. It can't go into 6. It can go into 15 and it can't go into 4. So that one's definitely going to go with there. Okay, but if you use the factor theorem, like it says here, stuck the number 2 into each of them, you would see which one it is going to be. So this first one, for example, if you put a half into it, you'll notice you get 0. So therefore, that means that 2 minus x has got to be a factor, because that makes that 0 as well. What about this one? Well, if you tried minus 5 over 3, try putting that in there, you'll notice that 3/5 is a factor, because 3/5 makes that 0. 5 over 3 makes that 0 as well. Okay, finally we just talked about this one. That's the only one that could fit with it. That's why 3/5 works. So therefore 5x minus 3 is a factor. And finally, this one, if you put the number 2 in, which makes that equal to 0, it also makes this function equal to 0. So therefore x minus 2 is also a factor. Okay, right, you don't need to take this down in your notes just yet. You just need to have a look through. So when you divide a polynomial function by a linear function, So any polynomial function you like, that could be an x cubed, an x squared function, it could be an x to the 4 function, it doesn't matter what size that polynomial function is. If you divide it by a linear function, like for example just x plus 2, then the result you get is the polynomial always 1 degree lower. Okay, so if you had something like an x cubed function and you divide it by a linear function, you would end up with 1 degree lower, which is a quadratic, plus some sort of remainder. So if you look at the answer to this, now the top line here shows that you've got a cubic function. So this cubic function here is getting divided by a linear function. That means your answer is definitely going to be a quadratic. You're going to have some sort of quadratic because you've got 4x cubed divided by 4x. But if you haven't noticed, it's worth spotting the fact that 4x plus 3 is not a factor of that top line. So unlike those first exercises you did, where you could factorise and just cancel out, this one doesn't cancel nicely. So what's going to happen, because 4x plus 3 doesn't go nicely into this, you are going to get some sort of remainder. Now you can actually calculate that remainder by using the remainder theorem. Right, but what we can write down is a quadratic equation. So if we divided it, we get the certain quadratic, which is there, plus our remainder in this form. Let me just show you where this idea comes from. If you imagine that you looked back at a very basic question, like for example 11 divided by 2. Okay, when you did that originally in primary school, that would have got you 5 whole ones, remainder 1. That's what you would have got from school back in when you used to do it in primary school. And that's how you might have thought about it to start with. Now that number 1 is not just remainder 1, it is 1 out of whatever you were dividing by, which is why later on you wouldn't write remainder 1 like that. You would write 5 remainder 1 out of 2, because that's what you were dividing by. And it's exactly the same when it comes to these type of things here. When you're dividing, even though they're algebraic, it still works out the same idea. Okay, right, just get rid of all that. There we go. Put my pointer back on. Right, so the question is, how do we calculate what parts these are? Right, so we can calculate the remainder by using the remainder theorem. So we know that, that's how we can calculate the remainder. We can work it out by using the remainder theorem. So there we go. In this case, minus 3 over 4 is what makes that equal to 0. So therefore that would help me work out the remainder. So the remainder is going to be 3. So what I can do straight away is substitute that in. I can put that into there, and therefore I know what the remainder part is going to look like. 3 remain out of 4x plus 3. I still have to work out what these parts are. So that's what we're going to investigate now. Right, just grab your notebooks. So we're going to have a look at solving the division by comparing coefficients, because you could have this written down as 4x cubed plus 11x squared plus 18x plus 12 divided by 4x plus 3. Okay, we've just written it in that way. So how do we work out what the A value is, the B value, the C value, these constants at the front, these coefficients? Okay, so the first thing I'm going to do is just get a common denominator throughout. Now this step here and then the next step is something that's worth just putting down in your notebooks, but realistically the more you practice these, you will just end up doing this part in your head. Okay, right, so look what I'm doing. I'm changing everything so it's got a common denominator, 4x plus 3. So if I want 4x plus 3 on the bottom of there, I've got to multiply by 4x plus 3 on the top, so that's what's happened. That's what happened to x squared. 4x plus 3 on the bottom, 4x plus 3 on the top, so that's bx times 4x plus 3, and so on for c, and also just for that part at the end, which is our remainder. Right, why did I do that? Well, now, because I've got a common denominator throughout, I can put them together with that common denominator. So therefore, now I know that that part equals that part, what I can do is I know that the denominators are equal, so therefore my numerators must also be equal. And that's what I can get at now. My numerator is equal to that. So as I said, these sections here, so these two lines, most of you will end up just missing those out. And you'll jump straight to this line, because if you look, it is just the numerator there with 4x plus 3 times by each part of these. So it's got 4x plus 3 attached to that bit, 4x plus 3 attached to that bit, 4x plus 3 attached to that bit, because you're multiplying by it, and that's cancelled the 4x plus 3 there. Okay, so you'll get used to just writing this line down. Right, why does that help us? Well, if we expand these brackets first of all, and we write out the equation in full like that, it looks like we have a right mess. But what we can do now is what we've done before on previous parts, is equate some of the variables. So for example, on this case, we can see that we got the variable x cubed. Now because these things are equal to each other, it means that all the x cubes on that side must be equal to any x cubed on this side. Right? So I can see that I've got 4 on that side, must be equal to 4a on this side. So that's what we're going to do. So that example there, let's just show that again. 4x cubed there has got to be equal to the 4a there. And because those two are equal to each other, it gives me a really easy equation to work out. 4 equals 4a, so therefore a must equal 1. Now I could do that for any of these variables. So x squares must equal x squares, x's must equal x, constants must equal the constants. So let's try x squared. What do I get? 11 must be equal to, well, the 3a and the 4b. Okay, because they've both got x squared at the end. Okay, but I know what a is. A is times 1, so I can put that back in because it's a constant. I've figured out what that constant value is. 11 equals 3 times 1, 3, plus 4 lots of b, so b must equal 2. Same idea for x. 18 must be equal to, in this case, 3b and the 4c. So there we go. I know what b is though. B is 2. So it's really 18 plus 6 plus 4c. So simple bit of rearranging gets me c equals 3. Now if you didn't work out the remainder, if you had left that as just a d value, because sometimes you have that, ax squared plus bx plus c plus d, and you don't use the remainder theorem, you could, imagine if that was d, that would be d, that would be d there. You could actually then equate the constants, and you'd have 12 equals 3c plus d, and then you could work out the d value. It's just easier using the remainder theorem, but you do not have to. Okay, you could still do equating for the whole thing. So what you do at the end, now all we need to do is just put it together. So there we go, write out your solution. That must equal 1 lot of x squared, 2 lots of x, plus 3, plus this part just here. And you could check that by multiplying these bits together and seeing that you get back to that. Okay? Right. You can use the grid method. Some of you may have used the grid method in year 1. So I'll show you the grid method. If you haven't seen the grid method before, or you don't want to use your grid method, I would say sticking at equating coefficients, and you might want to just skip past this part. But if you did the grid method in year 1 and you liked it, I'll show you the grid method for doing this. So if we're going to do the grid method, what you're dividing by can go down this side. The answer we want is going to go across the top, and this numerator here will go inside the grid. So let's start with 4x cubed. So the 4x cubed goes inside the grid, and we need to be thinking 4x times what gets me 4x cubed? Well, to me, 4x times x squared, right, is going to equal 4x cubed. And now I know that part of the multiplication, I can now fill in this part of the multiplication grid. So 3 times x squared, 3x squared. Okay, right, now I need to use the next bit. Now the point is with 11x squared is that I've already got 3x squared already. So I need the 11x squared, but I've already got the 3x squared, so therefore I'm going to need an extra 8x squared, so I can fill that part in. Okay, right. Then I go again. 4x times what gets me 8x squared? Oh, that's going to be 2x. 2x times 4x, 8x squared. That allows me to fill out this part of the grid. 3 times 2x, 6x. Right, now I'll go again. 18x. Now I've got 6x already. I want 18x, so I'm going to need an extra 12x. 4x times what gets me 12x? Well, to me that would be just the number 3. And 3 times 3 is 9. Now the issue is I wanted 12, I've got 9 so far, so I'm going to need an extra 3. Where does that 3 take me? That takes me to that D value. So that's 3 out of that. And there we go. I've got the end answer, which we know is the 3 which was saying there. So therefore I can work that bit out. So you can use the grid method, you could use the equating the different variables, or you can use algebraic long division if you got taught that in your first year and you prefer that. There is no preference when it comes to your exams. So whatever method you're comfortable with, you just do that method. Okay, on exercise 2.4, lots of division to practice. It's worth making sure you can practice this because later on they will expect you to know these skills as standard approach. So you're going to have harder questions that will involve these skills as like the easy part. So make sure you're nice and solid at it before you move on. Okay, so exercise 2.4 on page 239.